Right, the Argand diagram. So it's on page 47 of your notes. Okay, so you're going to have to bear with me. I'll just quickly set this up this morning. I don't know how it's going to work in terms of how I've laid it out and all that. Just a normal natural class set note. But I'll obviously spend some more time, hopefully next lesson, to do something a bit more. So, an Argand diagram is what we use to plot all the possible complex numbers. Okay, that it is in principle, the same as the Cartesian plane. That the horizontal axis is what we call the real axis, and the vertical axis is called the imaginary axis. So to plot a complex number in the form z equals x plus yi, we treat the real and imaginary part as the coordinate to the Cartesian plane. Okay, example, is z equals 2 take away 4i and w equals -1 plus 2i. We need to plot the following point, a and b, z and w. Alright, so we have our Argand diagram. Right, so the horizontal axis is your real axis. Okay, so we notate that as real of z. Okay, and the vertical axis is going to be the imaginary part. So we notate that as the imaginary of z. Right, so z is 2 take away 4i and w is -1 plus 2i. So let's plot z. So 2 take away 4i. Okay, so we've got the real part as 2 and the imaginary part as -4. So we treat that as the coordinate of the real and imaginary. So 2, -4. Okay, and we plot that point. And I'm going to label the letters in relation to the question. Right. B, which is w, -1 plus 2y. So we treat the real part on the horizontal and the imaginary part on the vertical. So -1, 2, -1, 2, the real and the imaginary part in order, and that's going to be that point there, B. Okay, so I'm going to use GeoGebra to list them. Working the other one, why it's not working yet? There you go. Okay, so there's our first two, so our V is going to be Z. Alright, so next we're going to have C equals V plus Z. Alright, so we're going back to the arithmetic complex numbers. So we have 2 take away 4i plus -1 plus 2i. Okay, so of course we add our real part and we add our imaginary part, and the result, I don't want, right, get it. Alright, so C, Z plus W equals 2 take away 4i plus -1 plus 2i. Okay, so going back to our previous lesson, we add the real part and then we add the imaginary part. So 2 take away 1 and then -4 plus 2. So we do the addition of those two complex numbers and we have 1 take away 2i. 1 take away 2i. That's C. Okay, so I'm labelling with the question number there. D, Z take away W, so we've got 2 take away 4i, take away, don't forget your bracket because you are taking away a term which consists of more terms, -1 plus 2i. Right, 2 take away -1, which is 3, and -4 take away a +2, which is -6. Okay, so we treat the real part on your horizontal axis and the imaginary part on your vertical axis. So 3, -6. Which is D. Right, E, ZW, so we have 2 take away 4i times 1, -1, sorry, plus 2i. Okay, so we need to expand that. -2 plus 4i plus 4i. Minus 8i squared. That, and I squared is -1. Right, you've got -8 times -1. Okay, which is a +8. Take away 2, which is 6. 4i plus 4i is 8i. Okay, so the real part 6 and the imaginary part is 8. Right, so I've got cut off with my notes. This is E. W over Z. So W, 1 plus 2i, -1, over Z, which is 2 take away 4i. So what do I need to do at this point? By conjugate. 2 plus 4i. And why do we multiply with a conjugate? Hey?
In a sense, make a fraction.
Yes, where the denominator is real. Okay, so we've got different two squares. Okay, so we'll create the denominator 0, so we can split our real and imaginary part. So -2 take away 4i plus 4i plus 8i squared, all over 2 squared, which is 4, take away 16i squared. Okay, so we've got negative 4i and plus 4i. Okay, so this number does not have an imaginary part, so it will be purely real. Negative 16 times negative 1, 16, so 20. Okay, so the division of w over z is equal to negative half. No complex part associated with that. So we just need to plot the real number, negative half, which will be, of course, on your real axis. G, Z, I. Okay, so Z is 2 take, what's that? Z is 2 take away 4i. Okay, and we want to multiply that by I. Okay, so it'll be 2i take away 4i squared, and that's going to be 4 plus 2i. Okay, so just a note, this is Zi. Alright, so we plotted Z as A. Alright, and G is going to be Z times I. So 4 plus 2i. 4, 2. G there. And A is down there. Okay. Now, the interesting property about that. Hey? Yeah, by what? Good. Okay. Because if I dot that there and there, we've got the right angle there. Alright, so we're rotating in any clockwise direction 90 degrees every time you multiply by I. Okay, very good. And H, negative W. So we've got W. Now we're going to go negative W for B, W is B. So when we plot H, I want to look at the relation with respect to B. So W is negative 1 plus 2i. And negative outside of negative 1 plus 2i is 1 take away 2i. Okay, so I want to look at the point H in relation to B. 1 take away 2i. Okay, which is the same point as C. H. B and H. Can you see the relationship between those two? B and H. A. Yep, or in other words, they rotate around 180 degrees because of the straight line. Yep. H is the same point as C. Yep, and B there. Yeah, so they rotate around 180 degrees. Okay, and we get the negative of the complex number. Okay, so, no, I didn't put it there. No, nope. Alright, so, in your notes, a few things come out of this. So the conjugates are reflected about the x-axis. We didn't actually do a conjugate there. Okay, but if you were to do a conjugate, there will be a reflection above your horizontal axis. Opposites, so W and negative W, which are rotated 180 degrees around the origin. And when you multiply by I, it will result in a 90 degree rotation anti-clockwise. Okay, so if you multiply by I squared, okay, you can think of rotating twice by I, and you have a rotation of 180 degrees, which is the same as the negative W, which is the rotation of 180 degrees. Okay, any questions?